Okay, so I'm going to talk about Lua today. I've been working a lot with Lua recently, and I really like it. It's a great language. We use it in the games industry quite a lot for scripting games. There's a couple of engines that are built around Lua, Defold or Defold, I don't know how you pronounce it, Love and Solar 2D, to name a few. We actually used it as a scripting language in Buzz, and many games use it. It's really easy to integrate into game, and it's quite small and efficient. And actually, I'm beginning to think of it as a kind of replacement for C, even though it kind of compiles. You can compile it to a C program, and it doesn't compile to C. It actually calls, there's a small Lua runtime that you call into, but it's quite lightweight and nice. So, but I'm calling this series Level Up Lua, and this is my first video in it. I'm hoping to do one a week, but we'll see how that goes. Life gets in the way sometimes. And what we want to talk about today, firstly, is, I've called it 5 steps to TDD Enlightenment. And so I'm going to go through sort of from a beginner's, first use of how to build up to test-driven development from first principles almost. And, we'll discover some useful debugging techniques on the way, hopefully. So to start off with, I needed to find some buggy code. And I needed not a stupid example like, here's how you do factorial in one line. No one needs to do factorial in my industry, and I think that's been solved. But I thought, I'm really bad at writing code, not TDD, but I want to write code as if I was, less experienced, learning the ropes. So I thought, I need to get some code that looks like code, but has a bug in it or is incorrect in some way. So I cleverly asked an AI to create a rope structure in Lua for me. So I used this really cool app I'm playing around with called Typing Mind. I get it in my set app subscription. And I asked it to make me a rope structure. I'll explain what that is. Go to here. Right, a rope data structure. So in Lua, and in most languages, the primitive of string is a string of characters, and they're kept in memory in sequence. And if you kind of add 2 strings together, 2 words like hello and world, if you concatenate them, it makes a new string, because you just cannot expand hello and world. Let me explain what I mean by that. So actually make a new file. Right. What I mean is that if we make a string hello, we add, so we concatenate, and to do that, use the dot dot. I'm going to put world like that. And we need to assign it. So if we do this, what we're actually doing is this is in memory and this is in memory, and if we used to print this out, we would get this string. So we've ended up, we didn't under the hood, as it were. On my key presses don't work. Didn't just do that, hello world. what it did was it constructed a brand new string by copying the hello and then copying the world. Now that's very inefficient if you're going to use this a lot. I mean, it doesn't matter in this toy case, but, if we can demonstrate that works. Lua, hello. So as you can see here, prints out hello world, as we expected. Now, but what it did was it all, in all of these steps, well, we've got this 3 strings here in reality, that are now in memory. So it can get very inefficient, and if you're gonna like build up a string over time, keep adding words to something, like that, then it gets really inefficient. So there is a data structure that kind of handles that. That handles that case, and it's called a rope. And it's called a rope because it's a replacement for a string. It does the same kind of thing as a string, but it's got a clever way of making it so it kind of expects to be growing and shrinking and being manipulated. So many text editors actually use a rope instead of a string to represent, all the text you're editing. And it means you can add stuff in the middle, like anywhere. And it doesn't have that huge impact that just using a normal string would. So it's, if you look on Wikipedia, it's a data structure. It's represented as a tree. Won't go into exactly how it works, but we'll figure that out later, I guess, when we investigate the bugs we're trying to fix. So this is a well-known data structure called a rope. It's again, it's useful for text editing programs where you've got lots of edits to a string to do, and there's some sort of implementation stuff here. So you can see shouldn't be that big. But I asked my friendly AI to come up with something. This is what it came up with. Why isn't my face in? That's annoying. Alright, well, this video will have no face. Why has that happened? I have to change a setting on resistance, but we'll do that for the next video. So it comes up with this. It's 125 lines of code, but alas, running it doesn't actually work. What a surprise. So we've got some non-functional code written by our colleague. Unfortunately, they didn't finish this off before leaving the company. They were replaced by AI or something, I don't know. But anyway, they've left, and we need this, and this is what we've got. It's not got a lot of help in here. So, as a beginner, how do we debug this? Well, everyone, first of all, will reach for... Right, so we seem to have a problem at line 66. So everyone, first of all, reaches for the old print debugging. So if we just print the node and I out here, then run the program, what do we get? Well, here we got a table. First run round, so it's managed to hit it twice, once with a table, and I is 8, and then we hit our error here, 0, 1. So how is this useful? I'm not sure. So So let's print some more stuff out. What is the index? And what is the string? So let's try that. Again, run the code. Okay, the index was 8. Interesting. And the string is world exclamation mark. Okay, so we're inserting at index with this string. So what? So I'm now kind of like, okay, well that must be this. Oh, it is that. So we've made a rope with this new. So I'm going to have to even go further into this and have a look at what new does. So using a tried and true, we're going to print the string, and then we're going to print the node. Then we've got an object here, and it's doing some meta table stuff. That doesn't, to be honest, I'm not convinced that makes a lot of sense. We've got a local variable named rope string and a function named rope string. So what the hell is that rope string? It's a table. Because it can't refer to that, and it should refer to this new function. So already, thank you AI, you are an idiot. But I love you. So we're printing out some other stuff. So we've got hello, we've got a table, we've got outward. So we're getting somewhere. Without having, like, the really old-fashioned way of doing this, by the way, was like you read the code and you execute it in your poor little human brain. So I would go, right, rope, new, okay, let's go into new, find it again, here it is. What does it do? And you'd have to really think hard about this, maybe even get your pen and paper out and draw data structures and stuff. That's what we used to have to do because we couldn't even print stuff. But I've got to the point where this is utter nonsense. I'm not even sure what we're doing here. Okay. But so that is a demonstration of print debugging. And we're not going to fix this code, honestly. I think we're going to go to the next step of debugging stuff. And that is to put assertions in. Or breakpoints. Let's go for breakpoints, actually. So this isn't really helping us. And we have to keep sprinkling prints around, and if there's a big loop, it's really the data. This fails so fast that we don't have a problem with too much being printed out, but you can imagine you get a huge amount of stuff printed out here, especially in a game where you've got like something happening at 60 frames a second maybe. You'll get a lot of printouts, and it's really becomes quite hard to understand what you're printing out. I didn't mean to do that. So we just generate a clean printout. So, I mean, we're okay, but what the hell? We've got memory addresses. We can't look into those. It's not very useful. So what we can do is if I set up got a debugger facility here, I can probably set up a new test. Let's do it rope. Okay. Need to set the working directory. It's a bit of a pain in the butt, this bit. I'm using the ME Lua plugin for IntelliJ. which is okay. What did we call it? Rope. Did we call it rope? No, it's called rope string. Apply that. Okay. So let's see if we can run it. No, we need. Is it configuration? I didn't put it in the code directory. Right. Okay. Run it. Yeah. So now we can. Now in IntelliJ, you can use whatever editor you like. I like to use JetBrains editors. Right, so we've got the same result we had in our own terminal window here. It's kind of nice because you can click and go to the actual line. So that's kind of cool. But we've also got this debug thing here, right? So we can press that and we'll start the debugging session. And we can press play and then it's played through. Now, but when we're able to use a debugger, then what we can do is we can set breakpoints. And if we then start up again, oh, this is so unreliable. Right, got it. So now it will stop at the breakpoint. And that gives us the opportunity to, instead of printing str, which I've still got, you can see that we've got str here. We've also got the rope string, which, tells you that it's got these functions, and to create node is a function, and the Lua environment here. So we can just plod along and press play, and it will go through again. So, but what we can do is, if we say we want to stop on root node equals create node, please work. Yep, that worked. We can stop there, and you can not only can you kind of step over, but you can step into. So I can step into this function, and I can look at what we've got here. So instead of printing stuff and then trying to work out the state of the code at any point, we can actually inspect it, go through, step over each thing, have a look. We're creating this object. I haven't printed this, but I can just step over it, and now I've got the object there, and I can look inside. So instead of just having a table address, so if I printed, when I printed root node, we just got an address like that, which is just a hex address. It's not very useful. But here we can actually inspect inside the table because it knows how to look in. This debugger is smart enough to know how to look into a table, and we can see the root is there, the value is there, and the weight is 7. The length of this is 7 as well. So you can see that how it's all being built. Now, obviously, this is meta tables are a really cool feature of Lua, but I don't really want to go into them now. And frankly, this is broken, and the reason this doesn't work is because this is broken. But we'll get to meta tables at some point. But this is about swapping out the prints for a debugging thing called, in this instance, it's called Lua. Again, you just start it up. It starts at the beginning, press play, it will stop at your breakpoint, and you can either skip over it or you can delve into it. And this is a really insightful way to kind of see how your code is running. And it's a really good way of starting. If you just stop, if you just stopped here and instead of doing all these prints, you actually stop, put breakpoints in and inspect the code, you'll get a better insight than trying to decipher what the terminal output is telling you. So that's step 2. So now we've done that, but you're still using, let's run it again. Sometimes it doesn't connect, I don't know why. But you're still using your human eyes, right, to figure out what's happening. Okay? And that's not what we want. We actually want to leverage what computers are good at, which is, if we expect, so let's put our breakpoint here, line 68. Right, we're going to look in, we were printing out node, but now we can look inside node. We can run it for the second time. Right, we've got node is nil. Now we were printing out that, but we're still using our human eyes to find this error. Now, the next level is to assert node not equal nil. So test your assumptions, and assert is a built-in to most languages. You can get an assert. Essentially is a condition and a message usually. So we say we're expecting node to never be nil here. But if it is, we're in trouble. So I'm going to get rid of all those prints I put in. I think that was it. And then I'm going to go back to just running the code. And here you can see that whereas I used to get where's the assert gone? It's in create node, is it? No. Yeah. So what used to happen is we get an attempt to index. So this is a reasonably good error actually for us. But what we've done is we've kind of enhanced that error message by just asserting it and giving some additional information. Node should not be nil. And we press play, you see the difference is there. Node should not be nil. It gives us a call stack to trace back to what called it. And normally what happens is this asserts, when you compile this for production, the assert becomes a no-op, so it just gets removed. So you should leave these in, double check before you do, and then literally you can start spreading these around. But then obviously if this has been called with nil, and this is obviously a lot faster, so, instead of debugging, keep trying to get the debugger to connect, instead of debugging this, and going, right, okay, let me look into this variable. Yeah. You end, when you're using debugger, which I do recommend, you do end up managing, where your breakpoints are, and sometimes we're lucky because this fails the second time round. So this is fine. The assert will pass and it won't fail. Next time round, this is where our node is nil, so this assert will fail. There we go. So you can imagine if that happened the 100th time round, that would be quite annoying to have to step through with a debugger. But if you just use the assert method, then you will instantly get there as fast as the computer can get there, rather than slowing yourself down all the time. So these are really handy to have. What it's telling us is obviously, if we go back up the calls track here, we could keep going back, right? So node.write. So let's run that. We get an assertion failed on line 77. We can add a useful message, node.write. Not be nil. Now, I'm guessing it should not be nil, but maybe if it's nil, we should just not insert it. I don't know, because I didn't write this code and I've got no documentation. Our chat AI didn't want to do that for us, and if it did, it would probably be wrong, and most comments get out of date really easy. So we've got no way of knowing what to do here. But we do know that we're finding out that that's happened. We could go back to here. So, okay, self.root. Sounds like that should never be null, right? So, let's go backwards through the code. And the thing is, breakpoints, you sort of come and go. They're sort of ephemeral. Whereas asserts, you can keep them in forever, right? And that's really handy. Should not be nil. So we can keep going, try and get closer to the okay, I didn't get closer, so self.root. Okay, well let's put and you can, as I'm now going to do, you can put these two techniques together. Oh, oops. So self.root is not null. So we're going to go in. Nice. And node.write doesn't exist. Just doesn't exist. Okay. So I've kind of got to the limit of where I'm going to get here, and I think that's quite good. We've got no guarantee how this code was written. Like, it clearly doesn't work, and we probably want to start again. So what I've shown you though is like, okay, we could unit test it, but because it's kind of broken, I don't know how we do that, but I'll write a quick unit test. So if I use Lust. I'm using Lust, which I think is a portmanteau of Lua test, but it could be anything. So I'm going to require that. And there's a couple of other things that you kind of tend to do. There's some key things you need. Describe. And I like Lust because it's a single file. Get it on GitHub. And it does the job quite neatly. I've actually got a modified version that I use at work. But, oops. Lust.expect. Can't program and talk. Lust.it. And then what we do is we use I think it's called behavior driven something. We describe our rope string by creating a function and expect, and we say it, and I would start with, well, if we do what we've got here, it can be constructed. So we do that, and then we use the function to give ourselves another context, and then we can write our expect. So we're gonna just copy this, right? So we've made a rope just like that, and then we can expect wrong button. We write a spec and we say to equal. We probably won't, I mean, naively I'm going to write this. And that's your test. So we can then press play. We're going to comment this out now, so we don't hit that error. Oh, yeah, don't comment it out the thing, the lust though. Right, so here we've written a test, so we're describing rope string and we're saying it can be constructed. And then to prove it, we use the constructor which is called new, and we say what we expect it. Now, it doesn't actually equal a string, so we probably have to and the great thing about unit tests is you can test just little bits of, and you can still debug it. So I can still run the debugger, find this bit, and go, okay, well, what is in rope? It's a root and value. So what we expect is the rope's root value to equal. And then we can play that. And what we've done is we've missed out space. Now we've got what we were looking for. This is our test. So this is one unit test. We've proved to ourselves, this is now documenting this better than this example usage. So before we had just that and then a comment saying it should output this, right? Which it didn't because it broke and crashed. So we've now started to convert this example usage code to, unit test world, just by describing it and saying what we should do. The next unit test would be it can be concatenated, string inserted. And then we create our context, and then let's make a new rope, and then let's do this code. So that should work, but we kind of know it won't. So here we can go, what would we expect? Well, we would expect, we've got this nice toString, so that's actually useful. So we can probably just use that in both instances. So we'd expect the ropes rope toString. So we're converting it from a rope to a string. And we'd expect that to equal. And then we're just going to put in what we expect it to equal. And we're going to copy that. Again, So now we've made another test, but this is also documentation, because this is saying you can insert stuff and this is what you should be able to see. And now if we run that, you can see our first test can be constructed, still passes, so we haven't broken that. But we've got a failure here, and it's failed at our assert. Now, because now we're in unit testing world, what we can do is basically remove the asserts from the code we're exercising, because we've essentially externalized that testing by doing this, because under the hood this expect is an assert. It's the same thing, right? You're asserting that, you're expecting or asserting that this rope2 string is going to be equal to this hello world string. So we can run that again, and we're getting the same original error that we had from this expectation. But now we've really narrowed it down, and we can put a breakpoint here. If we want to really inspect that, we can also, with last, we can think if I just do this. Winging it a little bit to not fail, I think. Let's see if that works. So this is now in the lost code. So alright, I don't know the right way of doing that then. Never wing it. I thought there was a to not fail. I think there is. I don't know how. Whether I have to make this into a function or not. Oh, yes, I did. So you can actually go, well, we expect this call within this function to not fail, and that's another valid, and you can see that, in fact, we've got a failure. It tells you where it's on this line because this function failed. So again, this is good documenting, self-documenting, unit testing of some code we didn't write, never saw before I started this video. So, and you could write a delete test. Right, so we could also, just to finish this off, and then I think what we do is do another video, part 2, where we use all of this to actually introduce the concept of test-driven development. So, can delete would be that. So what we're doing, we're still constructing this string, so let's start with that string. And, we don't want to pollute our test with too much stuff. So we'll start with that string. We're going to call the rope delete at. This might work, right? What's the chances of that? It might work. Oh, very funny. Of course it's not going to work. And we're expecting the output to be just the word world. So that we're now testing the delete at function, and we can run that test, and as expected. But the good thing is, right, and this is a good thing, is we've written 3 unit tests to test this code. We've gone through trying to debug it with printing stuff out. We've gone through putting assertions in the middle of everywhere. And now what we've done is we've got the best of both worlds, right? We've moved everything to this unit of code here, which could be in a different file and can be run as often as you like, preferably many, many times a day. And we've got some useful output in the terminal. We've got, tells us what passed. Great news. It seems to have constructed something that is vaguely right. And it fails completely to, in both the, can have another string inserted case and the can delete. I'll make that a bit more wordy. Range. Right. And you see how fast it is to run, right? And that's really handy. So we can just run our tests separately. We don't have this example usage. The example usage is described in this test thing, and that's what Lust is really good at. And we also can, expect a function to actually work without, failing. We can do as many different test cases. You could have an empty string and see, if delete worked at all. And you can just build as many tests as you want and keep running them and test the code. And this gives you a better understanding of it. Unfortunately, ex-colleague, has been done, was having a very off day when they wrote this. And we want to try again. We're going to use what we've learned on how you can debug code to actually reverse the order of how we do stuff. And it's called test-driven development. And once you grok it and understand it, you will never go back. So I'm going to describe test-driven development using Lust in Lua in the next video. Thank you.